On This Week in Enterprise Tech, we're talking all about software-defined storage. Fluke helps get your fiber clean, and you know what? Your supercomputer just may not be that super. Try it on the set.
Netcasts you love.
From people you trust.
This is Twit.
Bandwidth for This Week in Enterprise Tech is provided by CacheFly at CacheFly.com.
This is Twit. This Week in Enterprise Tech, episode 51, recorded April 19, 2013, for July 22nd, 2013. Turn off all the things. This Week in Enterprise Tech is brought to you by Jira, an Atlassian product. Jira is the product management solution for teams planning, building, and launching great products. To learn more about Jira and try it free for 30 days, visit Atlassian.com/twit. And by RingCentral. We do everything in the cloud. That's why I love my cloud-based phone system by RingCentral. Zero startup costs, and RingCentral is $20 per month per user. Try it now with a 30-day risk-free trial and buy one desk phone and get a second phone free up to 20 phones. Call 800-543-9980 or visit ringcentral.com and use our promo code TWIT. Welcome to Twit, This Week in Enterprise Tech. It's the show dedicated to the enterprise professional, the IT bro, and the geek who just wants to know what's going on in the world. I'm your host, Father Robert Balacer, the digital Jesuit, your guide to all things in the enterprise, and I'm joined by a small, intimate, but still classy panel, starting with the man to my right, Mr. Brian Chi. He's the evangelist for ThinLinks and the director of the Advanced Network Computing Laboratory in Honolulu, Hawaii. He's here with me at the Brick House. Chibert, how are you doing? Again, what are you doing here?
I'm actually talking to the chat room. We think we need to have a Padre Google Glass Kickstarter fund.
No. Oh, well, we'll get into that later on. But before we get to that, I do want to introduce our guest, a long-suffering guest. He was with us in episode 21. He's back now after some of my misfortunate, we'll just say scheduling problems. Francisco Gillette from Paragon. Francisco, thank you very much for coming in.
Thank you very much for having me back.
Now, for the folks who are playing along at home, can you explain to them a little bit about what Paragon does?
Yeah, absolutely. We provide backup and storage solutions, software solutions for small business to enterprise class customers.
Yeah, and if you've ever tried to, say, image your machine, ghost your machine, you've probably used some of their software, one of their suites. It's good stuff, and it leads right into the topic of discussion in our first segment. We're talking all about software-defined storage. Francisco, can you tell me, what exactly is software-defined storage?
Software-defined storage, or SDS, is a little bit of a marketing term used to explain software applications that create storage that can be used in your infrastructure. A lot of different vendors are starting to use this term, and instead of hardware storage like SAN devices, fiber channel, companies are leveraging virtualization technology or direct access to leverage storage for different needs.
Right. Now, software-defined storage, of course, it's going to bring up this idea of software-defined networking, which is something that's relatively new and something exciting in the field of enterprise tech. And that's the ability to dynamically assign your network resources as required. So, for example, I could have a physical plant back in my office, and I need so much processing power to do X task and so much processing power to do Y task. But as the demands grow, I can just order more processors online and have that horsepower delivered to me in real time. So tell me, how does that analogy apply to software-defined storage? Because it strikes me that it's not really the same. I can ask for more processing power, but it's not like I can ask for more storage and then give it back when I don't need it, because storage is storage. It's data, right?
Yeah, storage is physical storage, so you need to have those physical devices. But what this allows you to do is take off-the-shelf hardware that you can get and incorporate that as a SAN or as a NFS share or SMB share. So it basically gives you the ability to take existing storage that you may have or buy off the shelf storage and leverage it however needed in your environment.
Cheebert, let me ask you this. In the enterprise world, we're used to SAN or maybe NAS, really high-end NAS. That's how we do our storage. And in a SAN, if I want to give a project more storage, I simply go to the control panel, I add a couple of volumes or I grow a volume. How does that differ from what Francisco's talking about with software-defined storage?
Actually, what I'm really hoping it does is, right now, if you're defining a standard storage area network, you've got a lot of problems with, you've got to get the names correct, you have to deal with a lot of details on defining the LUNs, how it's formatted, how it's set up. You end up having to buy some very, very expensive, very complex software in order to get your servers to it. And God forbid you need to be able to share those volumes between, say, load balanced servers. What I'm hoping happens in software-defined storage is the same thing that's happening in software-defined networks. You start managing things as a piece, as a collection rather than a single entity. So instead of dealing with a single LUN, maybe, you deal with a storage entity or a storage instance that can be assigned to multiple locations and moved around as, you know, instead of having to say, I've got to copy this LUN from this array to that array, maybe I'll just say, I just want the instance to move, please.
Right. Okay, so Francisco, I'm going to come right back to you, but first I want Cheebert to explain how iSCSI would work. So we know iSCSI is a way of getting sort of almost BIOS level storage connectivity to any particular server or workstation. Let's say I'm running a small enterprise, 5,000 seat. How do I use iSCSI? How do I connect my storage to my servers, to my workstations in a traditional premise-based storage solution?
So iSCSI is basically, it's a network driver when it really comes down to it. And you assign what is typically a very long name that gives a uniqueness to the resource. And while, Sergio is saying, yeah, Windows can do a lot of what I was describing, it is very vendor-centric. iSCSI is one of those technologies that's nice because it is not vendor-centric. It's not operating system-centric. The same iSCSI NAS that I'm using for my Linux mirror site is also being used for a Windows machine to manage some other projects. And we're actually starting to play a little bit with possibility of showing iSCSI onto Android. I'm not sure if that's public yet, but we're tinkering. It's public now, isn't it?
Okay. Now, Francisco, let me go over to you. So we've heard about how it would work in a traditional premise-based SAN or NAS storage supporting iSCSI. Well, how would it work in software-defined storage?
Well, the software, typically the software would define these iSCSI devices or iSCSI targets. So it's, again, either using raw storage and making that accessible to the rest of the environment as a iSCSI target, or using virtualization technologies, essentially creating virtual disks that can be, again, assigned a iSCSI target and again used in your infrastructure, whether it's your virtual infrastructure as a data store or as multipath shares through iSCSI Initiator.
Okay, Francisco, we've been hearing a lot about software-defined networking. We've been hearing a lot about, say, OpenStack and the ability to move your services into the cloud, into a colo, private or public, whatever it might be. What does software-defined storage have to do with that OpenStack movement, into that virtualized infrastructure? What does it enable that I can't get out of my traditional SAN or NAS-based storage?
It's essentially the same thing. The benefit is it's a cost savings. So you don't have to invest in the hardware, the proprietary hardware to achieve that. So you can use, again, off the shelf, Windows boxes or even repurpose existing systems that you may have and create storage that you can use. So, with budgets being tight, it's a great way to get storage without having to pay that premium.
Okay. All right. Let's go to that ROI question. So let's say I'm building out a traditional NAS. I'm typically going to be spending, say, $250,000 to buy all the different boxes that I'm going to need, from the hard drives to the infrastructure changes that I need to make sure that I'm going to be able to get the throughput that I desire. What do I save by going to an SAS model? Or SDS, sorry.
Yeah, I mean, savings can be pretty significant, anywhere up to 50% or more. So, you could use that budget to do other things. So again, you're buying off-the-shelf hardware, or repurposing. Obviously, that's where you're going to realize your most of your savings. But you're not buying specific hardware. And another benefit is scalability. You don't have to go back to that proprietary vendor. You can, you just, if you need to increase your I/O, you can, put in another card, hire, a 10 gigabit card or a 40 gig Mellanox card to increase your I/O, instead of having to buy a whole new unit to get that upgrade.
All right. Chibert, let me go over to you. We hear this word scalability every once in a while, especially when we're talking about software-defined whatever, software-defined networking, software-defined storage. How big is software-defined storage and its ability to scale literally with a phone call for more storage resources when we're dealing with virtual infrastructure?
I think it's not so much the scaling as the ability to span multiple objects. One of the really cool things that happens is being able to, say, create a cluster that will span a high-speed link between two physical locations. Being able to more easily mirror storage, being able to assign the storage on an instance basis, being able to move it around. I think that's where you're going to save a lot of time and energy, because right now managing a traditional SAN is a royal pain in the behind. And a lot of times people tend to start having a dedicated warm body just to manage the SAN. And, OpenStack, kind of cool. We can move things around. We can provision as an instance. So instead of having to deal with a lot of details, I need, piece A, B, C, D, and E. Now I say I just want to have instance 1, and that consists of multiple pieces.
Got it. Francisco, let me go back to you. When we were dealing with the early days of OpenStack and the early days of software-defined networking, there was sort of a scramble for standards. Do we have a standard for software-defined storage yet?
They're still working on it. I mean, there's still a lot of people getting involved. All the big players are involved with OpenStack. Dell and HP, they're all involved. So it's definitely becoming more defined, and there are more standards. It's not, there aren't dedicated standards as of right now, though.
Okay. Well,
it's getting there.
The follow-up to that question would be, where do you see software-defined storage next year? So we're fast-forwarding 12 months. Hopefully, we've got some standard that most of the vendors have settled on. Where do you want to see it? I mean, Paragon being one of the leaders here in storage, how would you like to see it permeate the market, especially in the virtual infrastructure market?
Yeah, I think it's going to be a huge segment of it. It's definitely growing market share. Again, coming back to cost savings. You can get more storage for less money. So as more and more companies learn about it, they're investing in it.
Okay. Yeah. Chibert, over to you. Same question, especially since you deal with academia. Where do you see software-defined storage being in a year? Do you see us moving more towards a standard a la OpenStack, but for storage? Or do you see it kind of waiting for the winner of the software-defined storage wars?
Actually, I think it's going to be more along the lines of, will OpenStack and that type of thing become popular enough that it drives the private sector? Because remember, a lot of the OpenStack work right now, even though there are a lot of private sector people involved, has a very open source flavor to it. And there's a lot of people trying to compete, saying my way of thinking is better and so forth. I think a lot of things are going to shake out once OpenStack matures, and I'll just bet you there's an awful lot of people waiting to see what happens there, because then the hooks, the APIs, the software development kits and so forth will start being available so you can do some interesting things. I'll just bet you the guys at Paragon are saying, well, let's get started on something, but let's make sure we can move quickly because someone might make up their mind next month.
Right. Francisco, I want to give you the last word on software-defined storage. Here on Twiet, we've seen a lot of work done on virtual infrastructure. Everything from the clients to the servers that run behind the scenes to NVIDIA's big old grid cluster. There's been a lot of focus on the processing side, and that's typically what gets the eyeballs. We want to see the new hardware. We want to see what kind of performance we get. We want to see how much money we can save by moving things off of premise. But software is often an afterthought. Storage is often an afterthought because it's just assumed that that's going to come with the computing power. Do you believe that we will truly start to see these things as separate identities? That enterprises, when they're making their cloud-based service decisions, will see services separate from the storage that those services will run on?
Yeah, absolutely. Storage is a key part of that. The availability of that storage. We with virtualization, we've already have the ability to share resources for CPU and memory. With storage, that's where this is moving to. So you have this storage that's flexible enough that's versatile. That can be moved around and always available, high availability storage. That's the idea is to always be up and running. So that's definitely a key part.
And so one last bit, where should they go if they want to find out more about what your company is doing with software-defined storage?
Yeah, they can go to paragon-software.com. We actually have a high availability solution. We are partnering with Starwind Software, and it's a co-brand that provides high availability software in 2 or 3 node clusters that can give you up to 5 nines of uptime, so 99.999% uptime in a 3 node situation. So adding to the virtualization infrastructure, having your storage always available too.
Yeah, I like this. Oh, let me make you this promise. We want to have you back on Twiet where we can actually have you drive through your interface to show how easy it is to dynamically allocate your storage using your solution. Can I take you up on that in the future?
Absolutely. Absolutely.
All right. And thank you for joining us. And 60 seconds. Tell us, what is it that you want us to know about?
Just come see us at paragon-software.com. We have some new solutions, not just in the storage sector, but also we've recently released a new backup solution called Protect and Restore, enterprise level backup solution, highly scalable. It's a distributed solution, so it can fit from small enterprises or small businesses to enterprise class level customers.
Thank you. Francisco, I know you have to go, so again, thank you very much for your time, and thank you, Paragon, for letting us know a little bit about the world of software-defined storage. Now, coming right up, we're going to be going over a piece of gear that, if you're in enterprise IT, you can't get without. We want to welcome back to the Twiet Riot, a company that supports developers and product managers. Of course, I'm speaking of Jira by Atlassian. Jira is one of the world's most powerful and customizable issue and project management systems. It easily captures and organizes your workflow so that you can prioritize and take action on what's important while staying up to date with the activity going on around you. Now, here's a few of the things that Jira can do for you and your team. It easily captures, organizes, and prioritizes your team's issues, tasks, features, and bugs. It gives your team a simple, intuitive interface for collaborating with each other in real time.
It allows them to seamlessly integrate your planning documents, your backlog, your issues, and your code repository all on one platform. No more switching back and forth between tools. Set up any business process so that you can work the way that you want rather than the way that the tool demands. It also allows you to define your own issues, to track the information that matters the most to your team and their workflow. You can stay in the loop with notifications via email, chat, @mentions, or RSS, and monitor streams of activity or self-updating reports and dashboards so that you're always in the know. You can expand indefinitely in any direction with hundreds of Jira add-ons, including test management, time tracking, project management, and hundreds of other uses. Now, if your issues involve code, well, Jira ties everything together from an initial planning document, then files and change sets in your code repository all the way to deployment are recorded. Jira integration with Git allows teams to follow their code from development all the way through delivery in just one system, one single pane of glass. You can even build onto Jira yourself with the power of Atlassian's REST APIs. Jira is flexible and simple enough for a 5-person startup, but powerful and reliable and scalable enough for a 100,000-person enterprise. Jira is used by over 20,000 companies, including 70% of the Fortune 100 and NASA itself. Jira sits at the heart of Atlassian's offerings for managing your entire application development process from concept to launch. So here's what we want you to do. We want you to visit Atlassian.com/twit for more information on Jira to see what it can do for you and for your process. Monthly plans start at $10 a month for up to 10 users. You can try it free for 30 days. Now remember, that's Atlassian.com/twit, Atlassian.com/twit, and select Jira. And we thank Atlassian for their support of This Week in Enterprise Tech.
And we're back. We'd like to take some time now to throw some love towards all the gear-loving, card-carrying members of the enterprise community. Specifically, we'd like to take a look at a piece of fluke gear that might help you diagnose what's going wrong with your fiber plant. It's time for another episode of Pro Gear.
I'm Evan Poncelet, a software engineer with Fluke Networks. I'm here at the InteropNet Hot Stage facility in Brisbane, California, and I'd like to show you a piece of gear that the network engineers here use to test their network. This here is the OptiFiber Pro. It's an OTDR, optical time domain reflectometry device that has some very interesting features, as well as some layer 1 fiber inspection features. So what I'll show you here is a test setup that involves a launch cable, 100 meters of cable within a demo artifact, and a tail cable attached in series. And so there's 100 meters in here and an unknown event, which can be anything like a splice, a connector, a break in the cable, or something like this. And so I'm going to run an OTDR trace and show you some of the interesting features that we have that help make that a little bit easier for the user to interpret. So what I'm going to do first is go ahead and hit the test button. And so what this is showing you in real time is the fiber optic trace that's being done, or the OTDR trace that's being done. And you're also getting a measure of the quality of the bulkhead. And so I'll go ahead and show kind of what that is on this map. So I'll describe the sequences that I see on this trace. This is the event map feature, which is a graphical representation of kind of a more complicated presentation of the information of the OTDR trace. But what this does is show you each of the events that have actually occurred. And so what you can see here, if I click on this bulkhead, is the quality of the port itself. So that's the actual interface between the laser and the cable under test. In this case, we have a launch cable in front of it. So 100 meters is the length of this launch cable. So clicking on the launch event shows that as 0 meters. So we've essentially teared that out. So that's no longer a piece of the measurement. 6.91 meters in is a reflective event, which in this case is a somewhat reflective bad splice. Coming further, 103 meters down inside of this demo artifact, we see a ghost source. And I'll go into a little bit about what that is. And then 100 meters later, you see the end event here. And clicking on that just reveals that it's an end and what its distance is. And so I can click on any of these events and drill further to see additional details about that event. And so you can see here which wavelengths it was shot for. In this case, it was just 850 nanometers, standard multimode. Going back to the trace, we can also see a table of the different events that occurred. Just kind of an easier way of seeing exactly what the distances are, exactly what the reflectances were, as well as the loss. And you can do this for each of the wavelengths of measurement. In this case, just 850 nanometers. And I think we also swept for 1310, but didn't detect many events. You can also see the actual trace itself and scroll through the events as they occur on the trace. What I have here is a strand of multi-mode fiber with an SC connector on it that, as you can see, is a little bit dirty. So there's a lot of different grit that is along the end face of the cable. And so this can affect the actual transmission of light and reflect that light back to you. So it diffuses it a little bit. And so what that results is either poor link or poor quality of data transmission. So I can grade this pass-fail results so that this can be saved and exported as a part of the documentation on this particular run of cable. So what I'll show you now is, in contrast, what a clean cable should look like. Bring this into focus. You can see quite a bit of difference. So there's not any gunk or anything like this. And you can actually see here the jacket is the surrounding gray area, or sorry, the ferrule is the surrounding gray area. Inside here is the actual cladding, and then you can see the actual core there, which in this case I believe is 50 microns. So this fiber inspection can be done for a variety of different end face types, as well as multi-port optics. So there's a small mechanical attachment that you just fit to the end of this fiber inspection camera by unfastening these individual tips. So you want to make sure you have the right tip for the job. Another important thing that you can use for layer 1 testing or troubleshooting is the visual fault locator. Oftentimes that's just abbreviated to VFL. And so right now, this is actively shooting a red wavelength down the cable. So here, if you can make it out, you can actually see some of that red light leaking out. But that's useful for seeing exactly where the path of light is transmitting. So you can detect if there are any breaks. So these are all features of the OptiFiber Pro that are pretty important. Another mode that's important to talk about here is data center mode. So I can create a different multi-mode test data center. So each of these tests is independently configurable. And I can go in and set the different wavelengths that I want to measure. In this case, OM4 multi-mode. Data center mode allows you to transmit smaller pulse widths, which allow you to detect events that are more closely spaced. In this case, they can be spaced up to 0.5 meters. And so that's the OptiFiber Pro from Fluke Networks.
Thanks to Evan Poncelet for helping me explore a nice piece of Fluke gear. Cheebert, we've been playing with Fluke gear since, basically since we started enterprise work, because it's just been one of the biggest names. This OptiFiber Pro, using OTDR technology, what I really like about it is the fact that it can actually let me see multiple events on the fiber. Like if I have a kilometer of fiber, it can tell me I have events at half a kilometer, at 3/4 of a kilometer, and all the way to the end, all in one scan. How exactly does that work?
Okay, so an optical time domain reflectometer works just like its electrical cousin, but the whole deal is you're sending a pulse of light of a measured wavelength and of a measured length in time. You send that down, and then you look for reflections. So if you have a little kink in the fiber, you'll get a reflection. If you have a connector, you'll get a reflection. The whole idea about OTDRs is there's lots and lots of different ones out there, varying in price from several hundreds of thousands of dollars. But there's no such thing as a cheap OTDR. Even a less expensive OTDR is going to put you back several $1,000s. But it is a very sexy piece of equipment. It has to measure the length of a pulse of light and the return on that very, very accurately, because just a slight variation, and instead of, say, it indicating a break at 187 meters, it's now out at 200, and you're looking in the wrong place.
Right. I want to go back to a discussion we had about submarine fiber a while back. Someone told me that OTDR functionality is actually built into the repeaters, because of course it's not one continuous fiber. You have to amplify the light along the way, and so it's not as if you can plug in an OTDR into one side on, say, in New York and measure the fiber all the way to London. But since they've built OTDR functionality into the repeaters, they can actually have the repeaters report on the health of the fiber. That's crazy expensive, is it not?
It's expensive, but it's getting smaller. Like, for instance, a lot of the new SFP Plus, the 10 gig optics that are in little cartridges from various manufacturers have OTDR functions built in so that they can tell whether or not the contamination or the break is right at the connector or further down the line, and it'll actually measure the loss over that fiber. So you can have an OTDR function in something very, very small, very inexpensive. But the longer the distance, the more expensive the gear. So like, for instance, the OTDR that can shoot across, say, an ocean is probably going to put you back, I don't know, I'll take a wild guess at a couple million.
Oh, is that all?
Yeah, is that all?
Get a couple. Let's get two. Now, we have to use these when we're diagnosing the fiber plant at Interop because we are dealing with kilometers of fiber on spools. And so these tools have become sort of second nature to us. We have to have one when deploying. But I've also seen deployments where they have none of these tools. Essentially, the only metric they have is if they plug in the fiber on one end and I get a link light on the other end, that must mean it's working. Tell me what's wrong with that.
Well, look, I'll do an analogy. If you take a flashlight and you shine it through a bowl of marbles, you'll still see light. But how can you tell when the light is on and off? Well, if you're flashing it on and off really quickly, the reflections in that bowl of marbles are going to confuse you on when the light starts and stops. And that's the same thing that happens with, say, a cable crush. Or worse, someone goes and breaks a piece of fiber, but it's broken, but it hasn't separated. So it's just barely touching, and now the light's going in, and it's going from glass to air to glass. So because the index of refraction is changing, that creates a mirror effect. And so you're bouncing light back into the receiver. It hits the receiver and then bounces back towards the transmitter and back and forth in this ping pong effect. And you start getting FCS errors or basically late collisions. It's
right.
like someone flashing a light and someone else flashing a light right after them.
Yeah. Now, I see that you wrote in the chat room that the really long haul OTDRs are liquid cooled. That's because they have a significantly higher wattage shining through it, yes?
You got to put it in perspective. To get across the ocean, we need real lasers, not just light emitting diodes. And now instead of being milliwatts, we're talking about watts, hundreds of watts, thousands of watts. We're talking about lasers that, well, yes, you can look at it. You can actually stare into the fiber once. Well, actually twice, once for each eye.
Exactly. This is a question that we actually got out of the chat room a while back, and I put it in our Save for Rainy Day file. People who want to know how to get into this kind of work, one of the most exciting pieces of work that they want to get into is the sort of next generation telecom, laying down of fiber, especially with Google Fiber blowing up as it is. Is there something that people could do to learn up on the technology, to learn up on how OTDR works and why these tools are important without actually dropping the $10,000, $15,000 they'd have to pay to actually get an OTDR? Actually,
my favorite place to learn about these things are actually trade shows. And my favorite trade show for this is Interop. One of the nice things about it is a trade show designed specifically for the enterprise geek. And so you're not normally going to have just fluffy salespeople in the booth. You're going to actually have some engineers. You're going to have people that actually know what they're doing. And besides, there's also a fishbowl at the show called a NOC, Network Operations Center. And we've got an awful lot of people in there that really know how the tech actually works. They might have even helped write it.
Right. And if you do show up at that show and you see Cheebert and I sitting in the NOC, knock on the window and you know what? We'll give you an OTDR. Now, we'll be right back to talk more about these lasers. But before that, I want to take a word to mention another one of our sponsors.
When we built the brick house, we decided that we wanted as much as possible to be in the cloud. I mean, we believe in dog fooding. If we're telling other people to put their services in the cloud, why wouldn't we do it too? So when our IT guy came to Leo and told him that we could have a full-featured PBX phone system without all the PBX headaches and nightmares, well, it was a no-brainer. We love RingCentral. There are zero startup costs, no PBX hardware to install or maintain. RingCentral allows us to easily customize all of our call handling. Our producers can get their voicemail in their emails, and we can even get our fax messages right on our smartphones. And now they have a new feature, Business SMS. You can send text messages to customers and colleagues from your business phone number. No more using your personal cell phone. Now, here's what we want you to do. RingCentral offers all-inclusive pricing as low as $20 per month per user, so why not try it? You can start right now with a 30-day risk-free trial, and they have a special offer for my listeners. When you buy one desk phone, you get a second phone free, up to 20 phones. So call this number, designated for my listeners, 800-543-9980. That's 800-543-9980. If you say it 3 times fast, Beetlejuice will appear, 800-543-9980. Or you can go to ringcentral.com and use the promo code TWIT. That's ringcentral.com, promo code TWIT. And we thank RingCentral for their support of This Week in Enterprise Tech.
Now is the time of the show where we get into the Enterprise Bite. This story comes to us from Ars Technica. A while back, the fast, but not the fastest supercomputer in the world, they reported that they were going to retire. Just 5 years ago, the Roadrunner was built by the United States Department of Energy. It modeled the decay of the United States nuclear arsenal, which was, quite an important job. It cost $120 million to build and was based on custom-made silicon that was based on the IBM/Sony/consortium cell processor. So imagine a bunch of PS3s super souped up in a huge room that took up 6,000 square feet. It also had 296 server racks and 122,400 cores that were interconnected via InfiniBand. It was a fantastic feat of engineering at the time, and $122 million actually wasn't that much when you consider the kind of processing power that they were getting. Specifically, they were pulling down, I believe, 1.042 petaflops, which is enough now to have them ranked as 22. Well, Ars Technica reported a while back that the supercomputer was being retired, not because it wasn't fast. At number 22 on the supercomputing list, it's still plenty fast. The problem is that it is no longer efficient. And the reason why it's no longer efficient is because it pulls in too much power. Number 21 on the list, which is faster than the Department of Energy supercomputer, only required 1,777 kilowatt hours, while number 23, which is one slower, and just, I believe, 0.012 petaflops slower, only used half, 493 kilowatt hours, versus Roadrunner's 2,345. So otherwise, it was a power hog. Now, Brian, let me ask you. We've seen this in the past where old equipment starts getting retired because it's no longer cost efficient to keep it running. And it's not just the amount of power it runs, it's also the amount of cooling it requires and the amount of rack space that it demands. Is this something that we're used to seeing? Is 5 years a long time to keep running a single supercomputer?
Actually, 3 years is considered a long time. The University of Hawaii was part of the consortium with the U.S. Air Force that runs the Maui Supercomputer Center. And the Air Force actually retired a cluster called JAWS. Now, JAWS was interesting. It's all IBM computers, InfiniBand cross connects and so forth, pretty fast. But when they retired it because they wanted to get more power, one of the other reasons was there was an order of magnitude savings in the cost of running it. Now, if you draw, say, for instance, just under a gigawatt of power, that means you also need a gigawatt of cooling. And you got to start doing the numbers. Some supercomputer centers draw so much power that they have their own power substation. So anyway, the University of Hawaii Computer Center, the Information Technology Services people, actually inherited JAWS. But even though it was a perfectly good supercomputer, we only turned on part of it. And even half the old supercomputer was going to put us back close to $2 million a year in power. So you start getting into this, wow, by changing out the machines to something that's, say, twice as efficient, I can save maybe $1 million in power and cooling. Wow, that sounds all very worthwhile.
How much of that can be anticipated? And by that I mean, let's say Google's a company that has just racks and racks, warehouses, buildings full of servers. they moved in the early days from building their own, from having these beige boxes that they sort of customized with off-the-shelf parts, to now having completely custom parts that are specifically designed to reduce the amount of energy that is used and given off in heat. But even with something like that, how do you plan for their obsolescence? Do you just say, look, we're betting that in 3 years there's going to be a more power-efficient solution, and so therefore at that point it's going to be more cost-effective to junk the old servers and replace them? Where is that calculus made?
Well, you start looking at things like Moore's Law. How fast are we going to double the CPU capability? Where are we on that curve? Now, in the game of supercomputing, if you've ever managed to get to one of those supercomputing shows, you start learning these people are really, really obsessed with performance. And one of the things they have to keep looking at is how do they stay on top. You don't stay on top with old equipment. So that's one thing. Doing things like gene folding, doing things like trying to find the cure for cancer. That's an awful lot of math to be done. And the faster you can do it, the faster we can maybe cure cancer.
Here's a larger question. There was always a big excitement surrounding things like distributed computing, say the search for extraterrestrial intelligence, or now the Stanford project that's being used to fold proteins in a simulation. But it would seem to me that if a computer like Roadrunner with custom designed silicon with carefully controlled racks is no longer power efficient, then building a supercomputer out of millions of computers all over the place, all of different power requirements, all of different performance numbers, all of different states of energy consumption, that should be incredibly energy inefficient, right?
To an extent. We're talking about the difference between high-performance computing, or Beowulf clusters, and grid computing. High-performance computing is homogeneous machines. They're all the same. They're all predictable. We know how much power and cooling they're going to need ahead of time. Grid computing is horribly inefficient because for every one machine working on a small portion of that problem, you tend to have maybe dozens of others working on the exact same piece because you're not quite sure that machine's actually going to finish it. You don't want to leave a hole in your solution. So you duplicate it. In some cases, massively duplicate it so you can make sure that the solution actually gets worked on. And then, maybe machine number 7 gets the answer first. Well, the rest of the machines are going to be working on the problem until they check in. So that might be 11 machines worth of power and cooling that is now wasted.
Wow, that's not great. Now, there was a document put out by Google not too long ago where they talked about best practices. And they specifically brought up 5 points when designing a power-efficient data center. Number 1 was to measure your PUR, that's the power usage effectiveness. The second was to manage your airflow, essentially separating the hot and cold side so that you're not always intermixing them. The third was to adjust the thermostat. In other words, it doesn't have to be Arctic in your data center. Your computer will actually work at room temperature. You just have to keep it from getting overly hot, but not refrigerate it. The fourth was to use free cooling. As you mentioned, for every watt you put in, there's a watt you have to take out in heat. Well, if you can use a free cooling, an area that's colder than a typical ambient temperature, you save a lot of power that way. And the fifth was to optimize power distribution. I want to focus on that fifth for a second. One of the big buzzwords has been DC power. They say it's more efficient. Explain to me why it is more efficient.
Well, DC power means you don't, in a standard computer, you're going AC back to DC. That's what your power supply's primary purpose in life is. Most standard computers, it's 12 volts and 5 volts. Well, if I don't have to convert AC power into DC power, that's some efficiency I can get back. Now, the problem is if you start running DC power or any kind of power, AC or DC, over long distances, low voltages lose power much quicker than high voltages. So that means one of the things that's going to have to change is you're going to have to change the higher voltage, say 208 volt 3-phase, into DC closer to the computers. So it's going to be a real change in the way you handle power supplies. So anyway, one of the things I wanted to point out is if you look at an InfoWorld article, we called it Pimp My Data Center. Look at the date on that and how far back we did. The only piece that we couldn't do in Honolulu was actually free cooling because of the temperature.
There's not a lot of coolness in Honolulu.
But yeah, we basically took two offices, hacked down the wall, and tried to find best of breed pieces. And 4 out of those 5 points from Google, we did maybe half a decade ago.
I do want to talk a little bit about the Pimp My Data Center project, because I was on the islands. I was living there, 20 feet away from your office at the time. Although I think I see you more here in California than I did
probably
on the islands. That's weird. But it was an interesting project because you were trying to take some of the best of breed, best methods, best practices, and put them into play in a data center. And you did things like you controlled your cooling. You had the hot aisle. You had the cold aisle. And at one point, there were plans to create a special channel for all the hot air from the servers to be exhausted out of the room. But you weren't able to. Can you explain a little bit about how that worked?
Well, we actually thought, if we go and just pump the cold air into the side that goes into the servers and then forcibly remove the hot air faster, being laymen in the air conditioning world, we thought that'd be really good. Well, according to the air conditioning engineers, though, that creates an imbalance and it really drives air conditioning systems crazy. So they taught us that what we really wanted to do was have a hot aisle and a cold aisle so that the air conditioners straddle the hot and cold aisle so it sucks in the hot air and makes cold air out of it and makes the whole process much more efficient. In fact, the data center, when we finally got through, there's actually a 20-degree difference between the hot and the cold aisle, and it's very, very efficient and uses, I think we use almost 75% less power than the traditional computer room air conditioner.
Directory Wizard in the chat room wanted to know wouldn't it be better to create an AC-based computer rather than a DC-based?
Maybe.
He's joking, of course, but okay. Now, let me get back to this because we've got those 5 points. We've talked about managing airflow. We've talked about, the ability that you don't have the ability to use free cooling. We've talked about how you've tried to optimize your power distribution. But number one, this is sort of an enigma. Measuring your PUR, that's your power usage effectiveness. And this is what we were talking about in that previous story, which is they realized that per petaflop, they weren't getting bang for their buck. Now, in something like Pimp My Data Center, in your own neck of the woods, where you got to control everything, did you have a plan for replacing the servers as they became no longer power efficient for processing? Actually,
that's a very big part of what drove the project. And especially in this particular data center where we had a lot of clusters and a lot of some virtualized machines, we wanted to get away from the older machines that had very inefficient power supplies. We wanted to get away from the 50-60% efficient machines to the next generation that were upwards of 95% efficient. So we saved a lot of energy just by changing to more modern machines that had more efficient power supplies. And we also got more efficient on how we distributed our power within the data center. We're actually running bus bars, 225 amp, 3-phase bus bars, so that we can actually make changes to the power system in the computing center without having to shut everything down. It also saves us a ton of money because we call the electricians a lot less.
Right, of course. Last words on the supercomputing front. Let's take a look at let's say the top 100 supercomputers. And as you go down, you're going to see them at different levels of efficiency. Number one, of course, is typically going to be the newest, so it's going to be the most efficient. But if we do start disassembling supercomputers once they are no longer efficient, how do you see the list changing over the next 5 years?
Oh, supercomputers tend to be almost a national pride.
They really are.
Yeah, Japan's blowing a lot of money, and various other countries. Supercomputers, though, are changing. Cray actually has a desk-side machine. It's not that big. It's big, but it's not that big. It's nowhere near a whole room. But they're starting to use GPUs for processing. And the jury's still out. It's not as efficient because we've got a software lag going here. The toolkits need to change. Your typical supercomputer application, even moving from one Beowulf cluster to another, a lot of times needs to be modified. Say you've got more cores. You go from, say, a twin dual core based node to a dual quad core or a dual 6-core or dual 8-core. Now all of a sudden that means per instruction cycle, I can now do, say, 4, 8, 16 math functions. So you have to change the way your functions are set up so you can make more efficient use of each CPU cycle.
All right. As Janisku in the chat room is always reminding us, one of the most exciting developments in supercomputing is actually NVIDIA's Grid offering. They showed it off at CES, and they showed it, allowing people to play video games or do simple tasks over the internet with cloud-based services. But as you mentioned, with more and more of these applications taking advantage of the GPU, we may get to a time at which the next supercomputer is really just a huge chamber of graphics processing units.
Yeah, I'm absolutely sure it's going to be attempted. And my big question for the propeller heads out there, is it going to be scalar math or is it going to be vector math? Because that's actually a really big question now in the supercomputing world.
Right. This last Enterprise Byte, well, I just threw this in here because it just makes sense to talk about it at the same time that we're talking about supercomputers and data centers. It was a story from Computer World in Australia that brought up the possibility that perhaps the real ecological time bomb in terms of usage of electricity and production of carbon is not the data center, but wireless. That's right. They quoted a Greenpeace story that looked at exactly how much money and how much power was being used up to develop new data centers and how much was being used to develop new wireless services, everything from the cell tower to the servers that drive them. Now, the interesting thing about this study was that they found that even though right now data centers still use up way more power, their level of growth is sort of petering off, whereas wireless continues to ramp up at an exponential rate. Now, Cheebert, let's think about this for a while. Data centers are going to get more efficient. We're going to figure out more ways to squeeze every bit of performance out of every watt that's used. Whereas wireless services, the only real way to get more of them is to deploy more towers, is to push out more RF energy, is to find out more ways to push data over existing spectrum. So does it make sense to say that maybe in 10, 20, 30 years, wireless consumption of power is going to dwarf the colo?
Yeah, maybe.
Oh, you don't seem convinced.
I'm not so sure. The boys and girls of the RF engineering world are very, very clever. One of the things you got to keep in mind, in the RF world, you can actually duplicate a lot of really interesting circuits just by drawing them with some sort of metallic paint. And they're getting more and more efficient. Yeah, we're going to have more and more power being used for them because there's probably going to be more and more cells because they're definitely shrinking in size rather than growing. But I don't know. There's an awful lot of efficiencies. The Wi-Fi access points, let's use those as an example since it's close to home, are dramatically more efficient just in a period of 1 year. And by better making use of the spectrum and making your receivers more sensitive, you can get further out, or you could service more people with the same amount of power. I think we're probably going to start seeing a leveling off, and I don't think those are going to be straight curves. I don't think they're going to meet where everybody's predicting.
Right. Well, the study specifically quotes, let me give you these numbers just so you can get a bit more upset, and that is that right now they estimate that we're using 9.2 terawatt hours to deliver wireless services, whereas in 2015, they're predicting it's going to reach 43 terawatt hours to deliver all those wireless services. Now, to be fair, the study is not all that clear about exactly where all that energy usage comes from. I think they're also counting the servers that are driving wireless services, which means some of that, it's actually still a data center. But still, I mean, wireless usage is only going to increase. We're only going to see more and more Wi-Fi devices, more LTE devices, more devices that take advantages of pieces of the spectrum that are released and developed over time. So, well, what can we do to make it more efficient? What can we do to keep our carbon footprint down for all the mobile devices that we carry with us?
Turn them off.
Turn them off.
Yeah.
Okay. All right.
There's an awful lot that's happening in the RF world. I really got to stress that. Just the fact that 802.11n uses dramatically less power than 802.11b, and there's been a 3 years, 4 years in between? Not a whole lot of time. And, we're no longer talking about how many watts your cell phone has, but now milliwatts.
Right.
So I got to admit, there are a lot more of them, but it's going down in how much power each individual uses.
Well, T-Bird, I want to thank you very much for being on. Again, you have used up another hour listening to one of the most interesting, fascinating, and absolutely fabulous enterprise tech shows on the internet. And yes, I'm being modest. But thank you for being on. Would you like to tell the Twiat Riot what you're going to be doing in the month of July?
Well, I'm not sure yet, because we're pre-taping this.
We are pre-taping, but this is the future, so speak to the future.
I'm hoping, really and truly hoping, to be taking pictures of polar bears in Alaska.
Wow. Okay, I see. You got to tell me about that. We could plan that shoot. We may have trouble getting you in over Skype, since Skype seems to be having trouble coming in from San Francisco. But we'll give it a try. To you, I want you right now, if you haven't already, to subscribe to Twiat. You know why? It's not because I want to increase numbers. It's not because I would like for you to mention to your coworkers, to your friends, to your family, to your nana, that they should be listening to Twiat to understand what's going on in the communication world. No, it's because I'm concerned about you. I'm concerned that you're not having each and every single week of Twiat delivered automatically into the devices that you have, that you know that you love. If you go right now to twit.tv/Twiat, you'll find all the different ways that we can get Twiat into your head. That's right. You want it downloaded into your iPod? Yep. Your iPad? Of course. Your iPhone? That's a no-brainer. How about your Android phone or your Android tablet or your Zune device, your Surface? That's right. We'll get it to you. And the reason why we do it is because we love you. That's right, Twiat Riot. We care about you. Not only that, did you know that we actually film this show live every Monday? Well, not this Monday, but most Mondays. Let me go back about that part about the live. But did you know that most of the time we film live here at the Brick House, noon Pacific time? If you stop by live.twit.tv, you'll be able to see how the sausage is made. You'll be able to see all the things that we don't put into the download. And let me tell you, sometimes it's better than the show itself. Not only that, if you're here live, you can jump into the chat room at irc.twit.tv, and you can speak to wonderful people like Beatmaster or Cyberdog or the Mo85, the people who make Twit not just a broadcast medium, but an experiment in temporary community. Also, I'd like you to drop by the Twiat YouTube page at youtube.com/Twiat. There you'll be able to subscribe to our feed to find out the latest, what's going on in the Twiat Riot, and pick up all our episodes in all its glorious HD. Also, why not follow me on Twitter at twitter.com/PadreSJ. I'm really trying to increase my Twitter count because I want to get verified. And you know what, Twitter? Verify me. Verify me. Not for me, but again, for the people I love, for the Twiat Riot. Now, Jason, I know that by now, by the time that this actually airs, you will have a baby.
I certainly hope so.
Yes. But I do want to ask you this, and that is, do you know where maybe our audience could go to find the absolute latest news about Android, and maybe even how Android can make their life, their business, their enterprise a better place?
Let me think. Possibly twit.tv/AAA, which stands for All About Android, which might be, possibly the best Android source here on the Twit network. Because, it's Android.
That's just amazing.
Come on.
That's just simply amazing.
Yeah.
Thanks to you, Jason, for TDing each and every show. Thanks to Carson, our super producer. Thanks to Cyberdog in the chat room and everyone else here at Twit that makes this all possible. I'm Father Robert Balaser, just reminding you, if you want to know what's going on in the enterprise,